Good evening, everyone. So, how many familiar faces? 1, 2, and 3. Okay. Where are others? Disappeared. Okay, so let me take everybody's. So, my name is UDAYS, and I'll be teaching you physics part of your science. So, Anushka, I know. Anna, I know. Dash. Okay. So is Myra. Okay, welcome Myra. Shreya. Welcome. Anushka. Second Anushka. Anushka Sushanta. You. Who is Anushka Sushanta Sarani? Bharat. Welcome. Sharvi. Welcome Sharvi. Gayatri. Welcome. Ayan. Welcome Ayan. Sat. Welcome. then Tavleen, welcome there. Okay, so we'll begin with the light chapter, which is chapter number 9. So I think a lot about light you already know. So in this, we'll understand what is light, and basically we have to understand reflection and refraction of light by spherical surface. Okay, this is the topic of this chapter. Primarily, we are going to understand this. Okay. So, some recap before we proceed into this. So, I'll ask you a question. You should be able to answer. So, what is light?
Form of energy which possible see.
Yes. So, light is first of all, it is a form of energy. Which enables us to see things around us. Okay, so key thing is it is a form of energy. Okay. So second thing is in what form does it exist? Okay, energy it is, but how does it propagate? It helps. We said it helps us see things around. So how do we see things?
Eyes.
Huh?
By our eyes.
So eyes is a tool which recognizes objects, but what in between that?
Light gets.
Yes, like if I switch off these lights, will you be able to see things around? So in the dark room, you cannot see things, right? So suppose you have an object here, right? So there has to be some source of light which has to illuminate it. Okay? Now this illuminated light will be reflected, and then somebody can see it. Okay? So it is the optical information is carried by light ray. What is called as light ray. Okay, so what you need is a source of light, and you have an object. So what happens is the light incident on the object suffers reflection. Okay, so what is reflection? Bouncing back of the light by the object in the same medium. Okay, so it is traveling, light is traveling in air, and it is reflected back in air. Okay, so that's how this object is visible. The entire optical, any visual sensation is termed under something called as optics, whatever you see. So this optical information is carried by the reflected light. Okay. Then eye is a tool which will recognize it, brain will recognize it. So how this light is traveling? So there is a source of light and it is propagating in all directions. It is propagating in all directions, not just this one. When light is switched on, it's not that you are able to see only this object, you are able to see all the objects. Light is traveling everywhere and the reflected light is reaching you from everywhere. Okay? So some properties of light, let us understand. So first of all, it is an electromagnetic wave. Propagates. In a medium or space. Space is no medium. Okay, in the form of electromagnetic wave. Okay. So first of all, light propagates in a medium in the form of electromagnetic wave. So with what speed it travels?
8 to 10 to the power
8 meters per second. So the speed with which it travels is speed in vacuum or space. So this is the speed with which it travels. Yes. Okay. In space or vacuum, it travels with this speed. In all other medium, like transparent medium, through glass, through water, through air. Okay. Air is treated as space, right? But it is not exactly space. Okay. You can approximate air as space. So in all other mediums, speed of light is less than 3 into 10 raised to 8 meters. Okay. So this is then the rarer medium. So this is rarer medium. These terms you should keep in mind. Later on it will be handy. And all other mediums are termed as denser medium. So the speed of light is less in denser medium than it is in rarer medium. Okay. Now you can see the path. Okay. So path of light is called as ray. The path of light. Is termed as ray of light. Okay, so it's not just one ray. Okay, like if you have a laser torch, you will see a thin light ray, right? But if you have a torch, normal, it will be a thick beam. Okay, so the bunch of rays are called as beam. Bunch of rays. Traveling together is termed as beam of light. Okay, so I think this is sufficient to start with Noble property. So just jot it down quickly. There is the left side, left way. medium that we spoke about. These are of three types. One is free space, that is no medium. But medium could be like opaque, transparent, and translucent. Can we discuss these mediums? Can anybody tell me what's the difference between all these three mediums? We have all of these three available in this room.
Opaque does
So-
not allow light to travel through it.
Correct. So what is opaque here?
When
Yeah, like wall. Can you see things behind the wall? No. So the biggest test about the medium is, can you see things through it? Okay. So you can't see things across the wall. So wall has to be opaque, or the wooden partition. Transparent, the glass. The glass is transparent, through which the light can pass. So you can see things behind the glass. Translucent,
parts
partially. Do you have any medium here? Do you have translucent medium here in the room? Huh? Yes. This glass. You can have a sense that somebody is behind. You can't really recognize. So partially the light will be transmitted, but not like this. Here the light will be fully transmitted. Is that clear? So partially when the light is able to pass through the medium, that medium is called transmission. Okay. Now there are different types of reflection. One is regular, and the second is irregular. So regular reflection takes place by a smooth surface or plane surface, like a plane mirror, right? So if these are set of incident rays, right? Let's say these incident rays are parallel to each other, okay? So to draw the reflected ray, what you need is an imaginary line. So this is the point of incidence. You draw a perpendicular. So all the imaginary line has to be dotted. Okay. Then you have to apply law of reflection, which says the angle of incidence is equal to angle of reflection. Reflection. Okay. So this angle is equal to this angle. So in case of regular reflection, You see the incident ray as well as reflected ray, they are all parallel to each other. Okay, these are incident rays. These are reflected rays. So reflected rays are parallel to each other. In case of regular reflection. So here, the surface, reflecting surface is a smooth surface, not plane surface. Okay. So a glass is an example of plane surface. Now what about wall? Does it have irregularity or it is as plane as the glass? Wall is rough. It's not smooth. It is a rough surface. So if you magnify it a little bit, the wall will have a lot of irregularities like this. It will have some deformities. Okay. Now for a plane surface, the normal is a perpendicular, right? What about irregular surface? Because to draw the reflected line, we require a normal, right? So what is a normal on this surface? This is a normal. So for a plane surface, it is just a perpendicular. So if you look at this surface carefully, you will see that it has so many curves.
Unevenness.
Huh?
Unevenness. Uneven.
Yes, yes. So it has curve, right? So you can imagine this curve is a part of some circle. Can you imagine this? Isn't it? This curve, every curve, so every irregularity can be imagined to be part of some circle. Okay? And every circle will have a center. So anywhere if you want to draw the normal, that normal is nothing but the radius. Okay? So here, what is the normal? The normal is the normal to the tangent at that point. You know the theorem in mathematics that tangent is always perpendicular to radius. Have you studied about it? Huh? In 10th you must have studied that. Have you studied about tangent and radius property of a circle? Not yet? Not yet. So it will be introduced. You are in 10th now.
Yes.
Okay. You will be studying about it. So there is a theorem that radius is always perpendicular to the tangent at a point on a circle. In mathematics, you learn about it. Okay? So this is a property. At any point where you want to draw the normal, which is like a curvature, so that normal is nothing but the radius. Okay? That radius is the normal. So you can extend the radius on both sides. So what is this radius? This is the perpendicular to the tangent at that point. Tangent is a straight line passing through the point on a circle, and there will be only one tangent that can pass through that point on a circle. Okay, all these things you will cover as a here. Okay, so now, so having understood this, so where will be normal to this now? The normal to this will be, say, in this direction. So are they parallel? Like in this case, the normals are not parallel to each other, right? Now, so if I take the example of incident rays, obviously incident rays will be coming from some source of light. So they will be parallel to each other. They are parallel. But now you see they make different angle of incidence. And by law of reflection, here the reflected ray will be in this direction, whereas here the direction will be little away. Although this and this are equal, this and this are equal, but now you see the reflected rays are now not parallel to each other. So this is called irregular reflection. It takes place by irregular or rough surface. Okay. It is also called as scattering of light because the reflected light rays are scattered in all directions. Scattering of light also. Okay, so these concepts will be useful later on. So we have covered almost all the basic terminology related to light. Okay. All right. Okay. Okay, let's now also understand the types of images which are formed. Now, so basically there are two types of images, real and virtual. Now, you are familiar about image formation by a plane mirror. Okay. So, can you tell me the properties of image formed by a plane mirror? Let us say I have a plane mirror here. Some object is here. This is the object.
They have the same distance.
Yes. So, how the image formation will take place?
It is virtual, it is real.
Yes.
Same distance, the object has the
Same distance behind the mirror as the object in front of it.
Right.
So,
And same size
same size
of the object.
of the object. Okay. Is there any lateral inversion?
Yeah.
There is a lateral inversion also. So, these are some properties. So, properties of images formed by plane mirror. So, image is virtual. Okay, what is the meaning of virtual? So, it is virtual, and whenever the image is virtual, it has to be erect. Or erect is singular. It means upright. Like when you see yourself in a mirror, you see yourself upright. The image is just like this, not opposite. So that's upright. What is the meaning of virtual? Okay, you cannot touch it. Can you obtain it on a screen? Yes, no. Like I am seeing myself in the mirror. If I send my brother behind the mirror, will he see me there? No. So it cannot be obtained on screen. Okay. So virtual image property is it cannot be obtained on screen. So most obvious example is image formed by mirror. Then same size as object. Third, laterally inverted. What is the meaning of lateral inverted? So horizontal flipping, left it becomes right, right becomes left. It's not vertical flipping, it's horizontal flipping. So it is left becomes right, and right becomes left, or horizontally flipped. Horizontally flipped. This is the meaning of then it is obtained. Where is the position? Obtained behind the mirror. At the same distance as the object in front of it. Okay. Now we'll actually see that all these points are valid. So how do we obtain the image? What is the criteria for obtaining the image? We require minimum 2 rays. Okay. Now from the object, I told you when the light is incident on the object, it will reflect in infinite direction. But we need only 2 rays. Okay. So let's take any 2 rays. Now apply the law of reflection. What is the law of reflection? One angle of incidence is equal to angle of reflection. 2, the incident ray, the reflected ray, and normal
lie on the same plane.
at the point of incidence. Incidence lie in the same plane. So this you understood. What is the meaning of second statement? What's the meaning of second statement? Look here. Let's say this is your mirror. Okay? And this is the plane in which the light is incident. So let's say the light is incident here. So this is the point of incidence. Then it will be reflected in the same plane. This is the plane. Now let's say the plane was, let's say this is the axis, point of incident, plane is tilted. So if now the light is incident here, it will be reflected in this plane. Okay?
It won't go on the
No, in the same plane. Same plane in which the light was incident, the reflected also has to be in the same plane. Okay? The reflecting surface is this. And this is the plane of incident and reflection. It also bears it down. There are 2 different surfaces we are talking about. The reflecting surface and the incident and reflected surface. Clear? Okay. So now, so where will it be reflected? So you need a normal. To apply law of reflection, we require a normal. Draw 2 normals. Right? So now, when you reflect it like this, making it equal angle of reflection, just like this. Here also. This will be slightly bigger. This reflected ray is diverging. So if anybody watches from here, what will you feel? You will feel that these rays are coming from somewhere here. Okay, so when you measure this distance, so you'll find that OP is equal to U dash. So what this observer feels is that these rays are coming from here. So this is where the image is formed. So what is virtual image? How it is formed? It is formed at a place. Okay. From there, the reflected rays appear to diverge from. Okay. So these rays appear to diverge from this point. This is where the virtual image will form. So the reflected rays are not actually cutting each other. It is appearing that it is coming or diverging from it. This is virtual. Okay, yes.
So can we see this example over here, like,
Yeah, see yourself in the class. Huh?
can we take the example from that light always meeting?
Can you see this tube light reflection there? This light is also visible there as a, that is virtual image. Any image in the mirror is a virtual image. Okay. So is the concept of virtual image clear? Are you convinced or not? You have to get up and see for yourself. Are you able to see the image?
Yes.
So there are multiple tube lights visible. So they are virtual image. When you open the door, go there, you won't see it. Okay? Yeah. Next. Real image. Now, what are the properties of real image? This you have seen. Have you seen real image? Huh? Have you seen real image? What is real image, first of all?
It is not right, it is involved.
It is inverted. Yes. First of all, how it is obtained, just like virtual image, it is obtained at a point. Virtual image is obtained. These are the nitty-gritties that you should understand. Is obtained at a point where the reflected rays appear to diverge from. Okay? Or where the reflected rays meet when extended backwards. Either ways you can define. So these are imaginary lines. These are not actual lines. That's why we have shown plotted. Okay? So you have to be careful. So here in this case, you can have a third ray. So it is along the normal, right? So it will retrace. So the observer, when he sees from here, he feels that this light is also coming from here. So all of them, all three will meet at this one. So this part is real ray. This is image. Is that clear? So this is the convention while drawing the ray diagrams. Now where does the real image will form? So it forms at a point where the reflected rays intersect. Each other. Okay, physically intersect. So now it won't be like this, it will intersect. So what is the example of this? Formation of image by spherical mirror. So we are going to learn. Have you learned about formation of image by spherical mirrors? Have you? So far I think only plane mirrors, right? So this we'll see. This is the topic of this chapter. Okay. So example. Formation of image by concave mirror. Okay, I'll discuss about it probably in the next class. Do we have a break also? We have break at 5:30 for 5 minutes. Okay. What are the other properties about real image? These are always inverted. Real images are always inverted. So whenever you say the image is real, you always write inverted. Real images are always inverted. And what is the position? You look here, the virtual image is found behind the mirror, right? Virtual image is found behind the mirror. Is formed behind the mirror. Okay. Whereas the real image will form in front of the mirror. In case of lens, it will be opposite. We'll see that. Okay. So in this case, always form. Real image is always formed in front of the mirror. Right. So with these basics, you are ready to go further. So any questions till here? This is mostly, I think, just the revision. Okay. You must have come across all these terms. Have you? Or is something new in this? Mostly, I think you have come across these terms. If you have any doubt, you can ask now. Otherwise, we'll move into learning about spherical mirrors. Yes. Virtual image concept. So virtual image is something which cannot be obtained on a screen. That's the first fundamental. Most obvious example is your own image when you see yourself in a mirror. I mean, this has to be experienced. If you have a mirror, you see yourself, right? But is that image, is it appearing on a screen? Like when you go in a cinema hall, you have a screen, front screen. So when the reel through the projector, when the projector light is projected through the moving reel, so the image is now projected on the screen. So that is screen.
So the light beams are diverging.
Diverging if you want to magnify, because you want the reel is of this size, few centimeters, yeah. But on the screen it is magnified. Yeah? So yes, so you can magnify that image, you can converge it also. You can make the image diminished. So all these possibilities we are going to discuss. There are 6, 7 possibilities. Okay. So depending upon the application. For example, if you are using a microscope, there you are seeing a very small object. So there you would need to magnify. But in telescope, what do? So you see the heavenly bodies, and in telescope you actually see a smaller image. Okay. So you don't see moon as actual size of the moon. You see it in a compressed way. Understand? So it depends on the application. The bigger objects will compress, the smaller object will magnify. Okay? So it's a very deep topic, you will relate. So let's go step by step. Let's not jump into everything together. Right now, whatever we have discussed. So is anything to be cleared again? So far, so good? Now let's move on to, so plane mirror thing is over. Okay, till here we have also studied in previous grades. Let's now move on to spherical surfaces or spherical mirrors. So first we have convex or concave, and we have convex. So what is a concave mirror? So the reflecting surface is curved inwards, like this. Okay. So this is a concave mirror. This is the reflecting surface. Is curved inwards. And the outer surface is silver coated. In case of plane mirror, this is the reflecting surface and the outer surface is silver coated. Okay. And for convex mirror, it is like this.
Outwards.
The reflecting surface is bulged outwards. Okay, we'll discuss more details on the topic.
And we expect